Hello. Today we're going to talk about the rock cycle. The rock cycle is chapter 4 in our geology iBook. Okay, so it starts out with a bicyclist coming down a big sandstone cliff here. It says the rock cycle shows how any type of rock can become any other type of rock. In the last chapter lecture, we talked about how rocks are made of minerals. But rocks are not categorized into one of the 3 rock categories based really on the stuff that makes them up. It's more to do with how the rock was formed. What environment did that rock form in? Did it form deep underground? Did it form above the ground in an area where it wasn't subjected to heat? Was it once molten? Was it once in a riverbed? Those are the things that really make a rock a certain category, okay? And any rock, this piece of granite right here that you're all very familiar with, granite here in Minnesota, this could become any other type of rock. It could become a sedimentary rock at some time in its life, okay? Depending upon what happens to it, what kind of stuff it is subjected to. The rock cycle, which is illustrated right here, depicts how our 3 major rock types, igneous, sedimentary, and metamorphic, can convert from one to another. Remember from chapter 3, igneous rock is rock that was once molten. It was once melted and it cooled somehow, okay? So we've got 2 different types of igneous rock. Rock that cooled slow enough so that crystals could form within it, and rock that cooled quickly, so quickly that you can't even really tell one particle from another. You can't see really the grains inside of them. These are both igneous rocks. They're both very, very different. They're both very abundant here in Minnesota, granite and basalt. But one cooled slowly underneath the ground, and one cooled very rapidly outside of, or on Earth's surface, I should say. Okay, which one do you think cooled slowly? The one with grains and crystals, or the one without? If you said the one with grains and crystals, you are correct. This one cooled slowly. This is known as an intrusive igneous rock. Intrusive meaning it cooled inside the earth, so it cooled really, really slowly. This is an intrusive igneous rock. An extrusive igneous rock cools outside of the earth. Extrusive means outside, and that would be basalt. This actually erupted out of a volcano and cooled very rapidly outside of the earth. Okay? These rocks, if you look down here at this diagram, we're starting with an igneous rock. It can become any other type of rock depending upon the environment. So let's say it goes this route. All right, so it erodes away. Maybe weathering and erosion happens. Maybe it's subjected to a lot of water movement, and little bits and pieces of it come off and travel great distances, and they are broken up into tiny little bits called sediments, and those sediments then compact together on Earth's surface to become a sedimentary rock. Okay, so we have lots of sedimentary rock all over the world as well, and this rock could have potentially had pieces of something that came out of a volcano. Remember, it's the environment that it's formed in. It's not what makes up the rock or what the rock once was. Okay, so we go from an igneous rock to a sedimentary rock. Now the sedimentary rock, if it gets maybe buried down underground, either because of some kind of folding or faulting or tectonic plate movement that shoves this piece of rock deep down underground, it's going to be subjected to a lot of heat and pressure, and heat and pressure make up metamorphic rocks. My light just went off. Can you see me still? Metamorphic rocks make up, or heat and pressure make up metamorphic rock. So this could potentially become something like this. Remember that with metamorphic rocks, we can see the actual foliation or the banding of the different minerals because this gets so hot, but it doesn't actually melt. It gets hot enough that the minerals actually separate out from each other, and we can see bands of them in here. Now, had this rock completely melted, it would have mixed up just like a big can of paint and then cooled, and then you would see the mineral grains more evenly dispersed throughout the rock. This is an igneous rock. It actually melted. It mixed evenly. This rock here is a metamorphic rock. It got hot, it got squishy, but it did not mix completely, and those minerals stayed in these bands that you can see within them. It's called foliation. All right. So then think about that. What would have to happen to this metamorphic rock I'm going to pause this so I can turn the light back on so you can see me. Okay, we're back with light. That's good. Okay, so what would have to happen to this metamorphic rock, a rock that was made by heat and pressure, what would have to happen to this rock in order for it to become an igneous rock? Think about it. This rock was made by heat and pressure. What would have to happen to it in order for it to be put into this category right here? If you said melting and cooling, you are correct. Okay, if a rock, any type of rock is subjected to melting, melting is the key word. Igneous actually means fire. Okay, so igneous rocks are largely volcanic rocks. They were once molten and they cooled. Metamorphic rocks, again, heat, but not enough that it actually melts. It just gets kind of squishy. And then we have sedimentary rock. And any of these rocks can become any other type of rock, depending upon the environment. Our rock cycle has no beginning and no end. It's just like any of the other natural cycles, like the water cycle or the carbon cycle or the nitrogen cycle. There isn't really a beginning to it. It just continues. It's a continual movement of rocks through this cycle, exposing them to all of these different natural environments. Okay, just to review again, there are 3 types of rocks. Igneous rocks form from the cooling and hardening of molten magma. We can have 2 different kinds of igneous rock. Extrusive igneous rock will cool very rapidly, like basalt. Obsidian is also an igneous rock. It cools very, very rapidly, usually in water, and so it does not have any time to grow any crystals. So this would be considered extrusive. And then we have granite, which has lots of crystals and lots of grains. This is intrusive igneous. It cooled underground. Okay, next type is sedimentary. Sedimentary does not include any heat. There's no heat involved, which is why sedimentary rock is the home of fossils. We find lots of fossils in sedimentary rock, in some limestone or sandstone. Reason being, heat would melt a fossil, right? If you subjected a fossil to the heat of a volcano, that fossil will be destroyed. So it's not to say that there wasn't any fossilized organisms around where igneous rocks are made. It just means that the intense heat and melting destroyed those fossils. However, with sedimentary rock, the sediments break off of all of these other different rocks, and they sometimes travel great distances on wind or water, and they end up compacting and compacting and compacting and compacting, and they just get cemented together. Well, that's the perfect kind of burial for a fossil, right? Just layer by layer of sediments over the fossil will almost perfectly, in some cases, preserve a fossil. So we find our fossils always in sedimentary rock, okay? And then metamorphic rock, metamorphism means change. A metamorphic rock is kind of closely related to igneous rock in that there can be crystals because they can cool really, really slowly. But it's not so hot that it actually melts, which is why you end up seeing in a lot of metamorphic rocks, you end up seeing these separate banding patterns, which is called foliation. All right. I have a little video here. Okay.
Rocks are everywhere. They are large and small, heavy or light, porous or dense. But rocks in some shape or form can be found all over the planet. Different types of rocks are formed in different ways. There are three main types of rock: igneous, sedimentary, and metamorphic. Igneous is a word that means fiery. Igneous rock is formed when magma or lava cools. Sometimes magma cools slowly underneath the Earth's surface. This forms intrusive igneous rock, like granite. Other times, lava cools when it comes to the surface in a volcanic eruption. This forms extrusive igneous rock. Some examples of extrusive igneous rock are tuff, obsidian, and pumice. Igneous rocks make up about 95% of the Earth's crust. The next type of rock is sedimentary rock. Sediment is small particles of sand, mud, and organic material that settle to the bottom of water or land areas, often lakes or oceans. Sedimentary rocks are formed when sediment accumulates over time in deposits that form layers. These layers become squeezed and compressed over time until they consolidate into a rock. Sedimentary rocks are the types of rocks in which fossils may be found, since the process of forming sedimentary rocks can preserve plant and animal remains that are deposited into the sediment layers. Some examples of sedimentary rock are limestone, shale, and sandstone. The third type of rock is metamorphic rock. The word metamorph means to change form, and metamorphic rock is rock that has been changed by extreme heat and pressure. Sedimentary rock, igneous rock, or even other metamorphic rocks can be changed by heat and pressure into new kinds of rock. Metamorphic rocks can be formed by being deep under the earth where pressure and temperatures are high, or when rock near the surface is heated up by the movement of tectonic plates or magma. Different types of rocks become different types of metamorphic rock when exposed to heat and pressure. For example, shale becomes slate. Sandstone becomes quartzite. And limestone becomes marble. Rocks are slowly but constantly changing in something known as the rock cycle. The rock cycle begins with magma, or hot melted rock, deep beneath the Earth's surface. This magma becomes crystallized, becoming igneous rock. These rocks begin to erode or break down into small pieces because of wind, water, or other forces. The small fragments of rock are carried away as sediment when water passes over them, and are deposited in layers, which eventually become sedimentary rocks. Then, some sedimentary rocks are pushed below the surface due to tectonic activity, where they are exposed to heat and pressure, transforming them into metamorphic rocks. If the rocks are buried even deeper, they may melt and form magma, starting the cycle all over again. Of course, sedimentary and metamorphic rocks can be eroded into sediment, and igneous rock can become metamorphic rock or lava. But one way or another, Rocks all over the world keep changing from one form to the next.
Alrighty. Okay, there is a couple more things that we're going to talk about here. A few different terms that were part of your vocab if you were in this class prior. And my light turned off again. Hang on. Okay. Crystallization is one of the terms that we've talked a little bit about. We talked about crystals when we talked about minerals, but crystallization is just the ability for minerals to crystallize if they cool really, really slowly. Okay, so crystal growing takes a lot of time, which is why rocks like granite are considered intrusive igneous rocks. They have crystals, so they obviously cooled slowly. The only place to cool slow enough for crystals to grow would be underground, so they are intrusive. Okay, that can also happen with metamorphic rock as well. Crystallization can happen there as well, because there is so much heat. They don't actually melt, but there's so much heat that as the minerals cool, crystals can form as well. And this also is happening underground. It needs to be underground to have that high temperature for crystals to grow. Erosion and sedimentation, we talked about the difference between weathering and erosion. Remember, weathering is the breaking down of rock through maybe water tumbling it or raining on it or a waterfall. Weather can break down rock. The sun can actually break down rocks. And then those sediments traveling great distances, so traveling downstream or traveling in the atmosphere via the wind, that's erosion. That's the transport of material, the transport of sediments. And then the last term is metamorphism. When a rock is exposed to extreme heat and pressure within the earth but does not melt, the rock becomes metamorphosed, which means changed in composition. The actual minerals can change composition and the texture of the rock. So we can have a rock that looks very different. You can have a rock like this that becomes a rock that looks like this. You know, very different. Metamorphism can actually change the whole composition and look of a rock. Okay, so take home points here. Any rock can become any other rock, just depending upon the process that it goes through. Okay? We have a little practice question right here. And you can write this down. Those of you who have been in my class all along have that Google Doc that goes with this book. And you can answer this question: what might happen to an igneous rock to turn it into a sedimentary rock? Okay, so what happens for a rock to go from this to a rock that looks like this, the sandy sandstone or something like that? What has to happen to this in order for it to become a sedimentary rock? And if you need help answering that question, go ahead and click on this little practice link right here. Okay, that'll help walk you through the rock cycle. Hope that works on your iPad. If not, just type in the rock cycle too into Google, and you're going to get a lot of different simulations. Okay, we'll talk a lot more about this. This was just an introduction. We are going to do a lot of work with the rock cycle. So I will talk to you soon.